Ang topic natin ngayon ay Basic Laws of Electrical Circuits 1. Ano-ano ang mga ito? Ito yung mga Ohm's Law, Kirchhoff's Law, Series Resistor and Voltage Division, Parallel Resistors and Current Division, and Y-delta or delta-Y transformation. Lahat ng mga ito ay magagamit natin all throughout our course. Even na gagamit tayo ng network theorems on our advanced circuit analysis. These laws will be our fundamental laws and sila yung magiging go-to equations natin in order for us to derive yung mga advanced network theorems equations. Umpisahan natin sa Ohm's Law. Ohm's Law is actually a law that states that the voltage across a resistor is directly proportional dun sa current na magfo-flow dun sa ating resistor. And in order for us to represent this law, kailangan natin ng constant of proportionality. So that is V is equal to I, and our constant of proportionality ay yung resistance ng ating load. Okay. Kapag sinabi nating load, ito yung mga passive elements, kung matatandaan nyo. Passive elements sa circuit, meaning to say that they do not generate electricity. So, ano nga ba yung resistance? Ito muna yung focus natin bago tayo dumiretso sa definition ng Ohm's Law. Resistance is the characteristic of materials to resist the flow of electric charge. It is represented as R. Resistance is equal to the resistivity of the material multiplied by dun sa quotient ng length of the material over dun sa uniform. Okay, uniform cross-sectional area, which is in square meter. So, meaning, yung ating resistance ay nakadepende dun sa innate property, okay, ng mga material na ang tawag natin doon ay resistivity. So, ang symbol natin sa kanya ay ito. Ang tawag siya ay quick letter rho. Okay, pansinin natin na kapag meron tayong mga formula sa circuits, lagi nating tinatandaan yung mga units niya. So, in order for us to get resistance, which is in ohms, ang unit natin for resistivity is in ohm meter. Okay, yung ating length in meter, and yung ating area. Okay, this is a uniform cross-sectional area, which is in square meter. So, kapag in-evaluate natin to, maka-cancel out ito, matitira isang M, and then cancel out din to, at saka yun, ang matitira is a unit in resistance, which is in ohms. Okay. So, sinabi ko nga na nakadepende yung resistance sa resistivity ng mga material at innate property or characteristic ito ng mga material. So, paano natin malalaman yung resistivity ng material? Meron tayong mga tables. Okay, pansinin natin itong ating table. Okay, tingnan natin yung mga elements na nasa taas at saka yung mga elements sa baba at yung kanilang corresponding resistivity value. Okay, mapapansin nyo, yung mga material natin sa bandang taas, itong mga to, ang kanilang resistivity or yung raw value nila ay masyadong maliliit. Kasi tingnan nyo, raised to negative power. Okay? Raised to negative power sila. So, kung titignan natin kung ano yung mga material na yon, ito yung mga silver, copper, aluminum, gold, carbon, germanium. Itong mga banda semiconductor na sila. Ito yung mga kadalasan ginagamit natin sa mga circuits natin sa bahay. Ito namang mga itong bandang gitna, ito naman yung mga element or material na kadalasan ginagamit sa mga gadgets natin. So, sila yung mga tinatawag natin na conductors. Okay, mabababa yung kanilang resistivity. Okay, so ibig sabihin, nakakadaan ng maayos yung flow of charge or yung current sa kanila. Kaya maganda silang gamitin sa mga circuits natin. Para naman dito sa baba, ito yung mga paper, mica, glass, teflon at napakataas ng kanilang mga resistivity value. So ang tawag natin sa kanila, yung alam natin na insulators. Okay? Next, ang symbol natin for resistance ay ito. Ito ang figure B. Okay? Kapag sa circuit analysis na tayo, makikita natin na yung resistance symbol natin ay itong zigzag line. Okay. And kapag ang problem is about the resistivity of material, halimbawa pinapahanap yung resistivity ng material, we should note that if, for example, cylindrical yung ating material or it is a wire, so pwede natin siyang i-figure as ganito. Okay, the length, ito yung length ng ating material. Okay, and take note ha, the area should be a uniform cross-sectional area. If we cut, okay, the material cross-sectionally, okay, yung makikita nating area, that would be our area na isa-substitute dun sa formula. So, if given, so, for example, this is a cylindrical material. So, kapag binigay ay hindi directly yung buong area, rather, let's say, R ang binigay, the radius or the diameter, we can use the equation of yung area ng circle to find the area. And then substitute that to the formula natin sa resistance. Okay, so ito yung symbol natin sa ating resistance. Okay, kapag may mga load tayo sa ating circuit. So this is George Simon Ohm, the physicist that coined the most basic law that relates voltage and current of a resistor. Okay, so ito na yung ating definition ng ating Ohm's law. It states that the voltage across a resistor is directly proportional dun sa current na magpo-flow sa resistor natin. And to represent that, again, in terms of a formula, we have to introduce the constant of proportionality, which is the resistance ng material. And previously, sinabi ko nga that R is actually dependent sa ating resistivity property ng material. Okay? Multiplied by the quotient ng length over the cross-sectional area. And itong resistivity natin ay may mga value siya. Okay? Na innate. Okay? Innate characteristic ng mga materials natin. We can represent Ohm's law in terms of R is equal to V over I, or I is equal to V over R. Okay? There are other forms ng ating Ohm's law. Okay, pero mas madali kasing matandaan, I suggest kung ito na lang, and then we derive kung ano man yung unknown sa problem. Halimbawa, pinapahanap yung resistance, we can derive resistance in terms of this, and pinapahanap yung I, we can derive that in terms of this. Kasi mas madaling matandaan siya. V is equal to IR lang, or VIR. So, VIR lang isipin natin. And another unit analysis, 1 ohm, okay, 1 ohm is equal to the unit of voltage is volt, the unit of current is ampere. So 1 ohm is equal to 1 volt per ampere. Now, how about sign convention? Okay, take note, if we have this element in a circuit, okay, if the current flows, okay, meron tayong current na magfo-flow sa ating element from positive to negative, polarity ng voltage natin, or from higher potential to lower potential, our V, or the voltage across the resistor, is positive. But if baliktad naman, okay, pag ganyan yung ating current, okay, opposite ang flow ng current natin. So the current flows from the negative terminal to the positive terminal of the voltage, or from lower to higher potential, then V is equal to negative. The voltage drop across the resistor is negative. Okay, maliwanag? This slide is very important, no? Kapag nasa advanced network theorems na tayo, there are cases, for example, sa Thevenin and Norton, na yung ating circuit ay magiging short, okay? And sa Thevenin, yung ating circuit ay, we will consider or redraw the circuit into an open circuit. So, kailangan nating malaman ano ba yung nangyari or mangyayari if the circuit is a short circuit and if the circuit is open circuit. So, unahin natin sa short circuit. So, ito yung figure niya. As you can see, okay, yung ating wire, okay, yung connection natin dito, dire-diretso siya. Meaning to say, walang hindrance or walang nag-oppose ng flow ng ating current. So, meron tayong value. Meron tayong value ng current, but the value of R, since dire-diretso flow ng current, walang nag-oppose, the value of R is 0. Then, ano ang magiging value ng voltage natin across that system? So, if R is equal to 0, meron tayong value ng I whatever the value of I na minultiply kay 0, the voltage is always equal to 0. Again, I repeat. So, short circuit, okay, wala tayong value ng R. R is 0. Okay, R is 0. Okay, meron tayong value ng I. Meron yan. Okay, meron tayong value ng I. But, if we get the value of the voltage across that system, so I times R, this is 0, that would be, our voltage would be 0 also. Okay, malinaw yon. How about sa open circuit? So, open circuit, open talaga yung ating system. So, ang magiging element natin between these 2 points, itong open na point na to, is air. And the resistivity of air is approaching infinity. Ibig sabihin, mataas yung resistivity niya. So, meaning to say, the resistance is also approaching infinity. Okay, kung may voltage, okay, sa open circuit current ay system kasi, or open circuit, ang voltage natin across this part ay merong value. Meron tayong value ng voltage. Okay, ang tawag natin doon ay open circuit voltage. Okay, if R approaches infinity and we have a value of the open circuit voltage, ano yung value ng I natin? Since I is equal to V over R, okay? So I, we have the value of voltage, and R approaches infinity. So the resistance approaches infinity. We can apply limits, okay? So V over R, whatever the value of the voltage, if R approaches infinity, the value of current is 0. So, kung maaalala nyo yun sa calculus nyo, sa differential calculus. Therefore, sa open circuit voltage, meron tayong open circuit, therefore, sa open circuit, meron tayong open circuit voltage, usually V sub O ang notation. Ang R natin is approaching infinity. Ang ating current ay 0. Okay? So, i-write natin ulit. Sa short circuit, okay, ang ating R is 0. Okay, meron tayong value ng I. Meron yan. So, we have a value for I. Let's say, ganyan ko na lang. Meron tayong value ng I. But, V sub V is equal to 0. So, open circuit naman, okay, meron tayong value. Ano meron tayo sa open circuit? Meron tayong open circuit voltage. Ayan. Meron tayong value niyan. Yung R natin approaching infinity. So, therefore, ang I natin ay 0. So, yun yung mga kailangan nating tandaan when we are dealing on short and open circuit.